Good morning to Dr. Ayub and Dr. Rahil. My name is Milton Makwakwa and I'm going to present my major equipment design, which is the CO2 absorption column C201. So the content of this presentation is introduction, design methodology, which comprises of process design and mechanical design. Then I'm going to present my specification sheet and also drawing of equipment. In a different section, we can find our Q&A. So in this problem, we have to reduce the carbon dioxide from the flue gas, and in order to do that, we have chosen absorption process, and the solvent that we selected is ammonia solution because it is cheap and it has the ability to not damage other components of the flue gas. So this is a figure where we can see the compositions of all the inlet and outlet streams in the absorption column. The design methodology, as I said before, comprises of two parts: process design and mechanical design. In process design, we select the column, we select the packing material, we calculate the sizing, diameter, we determine the number of transfer units and also the height of packing and the height of column. We calculate the operating and flooding velocity, then we determine the pressure drop, then we do the selection and design of internal fixtures such as packing support, liquid distributors and redistributors. In mechanical design, we do material selection, then we calculate the operating parameters and then the thickness and shell diameter. Then we calculate the head and closure, then we select and design the flanges, then we do the gasket design, the bolt sizing, the design of vessel, then we do procedure of stress analysis, column support skirt and nozzle sizing. Process design. We have chosen pack type of absorption column because the flow rates of gas and the solvents are very high. Ammonia solution is corrosive, which can cause damage to plates if we chose this kind of arrangement. Also, the liquid hold-up in pack column is lower. Since safety is a major concern in this design, and the materials that are being handled are toxic, the pack column is preferred. The pressure drop per equilibrium stage is also lower in this kind of arrangement. Process design. The packing type chosen for this column is interlock saddles, mainly because they are adequate for high flow rates. They have good loading elasticity. They have good resistance to strain. They are strong and resistant to corrosion. They are easy to operate and they are relatively cheaper. So these are the various design data for various packings. So these are our material balance calculations. Then we managed to get the number of stages by my Kaplan method, which was found to be 9. Then we did our process design calculations using the factors. We calculated the diameter, the height of column, and then the operating and flooding velocity, and also finally, we calculated the wetting rate and also the differential pressure. From mechanical design, the first thing that we did is material selection, and we chose carbon steel because it is highly resistant to corrosion that can be caused by ammonia solution. Then we proceed to the operating parameters, which is design pressure, design temperatures, and design pressure is 10% more than operating pressure, and the design temperature is 5% more than the operating temperature. The design stress was found in the literature. Then we proceed to the thickness and shell diameter, and these are the values that we found. And also we managed to do the head and design of head of enclosure, and then we proceed to the gasket design. After that, we managed to go to the bolt sizing and design of flanges. Then we proceeded to the design of vessel, and we did our stress analysis and elastic stability analysis. Then we proceeded to the design of column support skirt and to the nozzle sizing. So these are in this specification sheet we managed to find, we managed to show all the things that we found during our calculations, and this is the drawing of our equipment. Of the arrangement of the packing here, it will be dumped, and these are the data for our diameters. So it can be shown in our drawing of equipment. So this is the end of this presentation, and any questions can be asked in the question and answer session.